So my name is Chandan, and I'm an assistant professor here in educational technology. And today we'll be doing a little bit of sort of like so you're in a workshop, so you'll have to do some work. I'll do some work. So it's sort of like a collaborative discussion process that will go on. And can anyone mention a point or two what you have learned so far from the workshops that you have been attending? Anything, any words that come to your mind, anything that really struck to you as very interesting or even very boring? Can everyone hear me? Okay. Anything up till now, like anything that's struck you as to be very interesting, or something that you were not aware of before, something new? Anyone? Yeah.
Paper writing.
Huh?
Paper writing.
Paper writing. Okay. You found that interesting or boring? Interesting. Okay. Yeah.
The differences between IIT versus NIT versus state colleges.
Okay.
And so many things.
What's the biggest difference?
Flexibility.
Okay, flexibility in terms of like doing what you want to do.
You want to it's possible here, but as you go down the earth, it's not possible.
Okay. Anything else? Okay. So about the flexibility point, yes, there will be differences in terms of policies and all between colleges, and also the openness of the administration to accept new teaching styles, new ways of doing things. And you'll face resistance, and that's part of the change process which you are all sort of like trying to achieve in your own colleges. And I heard a little bit of what the previous speaker was talking about, and also what Professor Patwardhan was mentioning about you being the flag bearers. And I know that there are challenges from based on wherever you are coming from. So there's a team from Nalanda University, right? Nalanda, okay. And where else? Like where are you? Which other university are you coming from? I think Agartala. Okay. Okay. So all these places will have their own local challenges as well as like the administrative issues that we discussed. We cannot solve those in a workshop, and that's something that's we have to sort of like see how much is possible and how much is not. But what I would like you to take away from this workshop is like these are techniques which will remain with you. So we'll do a lot of teaching strategies and how to interact with students, what's been found from research and all. So these are not college specific. You take these with you to wherever you are going next. So with that mindset, I would like you to engage with me and like participate in a group discussions and all. Not be constrained by the limitations of your current place. So how many of you have heard about the word pedagogy?
The art and science of teaching.
Art and science of teaching. Okay. Okay. Any other definitions?
Exchange of knowledge.
Okay.
Exchange of knowledge.
Exchange of knowledge between teacher and student. Okay. Okay, those are two fair points. So what we'll be doing, what we'll be focusing on in today's talk is how we can combine pedagogy, content and technology, and how we can weave them together to make instruction in the classroom more effective. Now, you are all already experts in the content area, and that's something which we won't be covering. But we will be covering a little bit of technology, different types of technology, as well as different types of teaching styles. So when I say pedagogy, I mean teaching and learning strategies. So very similar to the definitions which two of you mentioned. And I'll use one example as a way of sort of like anchoring our discussion. I'll use one example of technology. It's called Energy 3D. It's a computer-aided design tool. It's a free open software, and I can show you where to download it from. It's a Java-based application. It runs on Mac as well as Windows, and it helps students visualize and design energy-efficient houses. So you can weave in different aspects of energy efficiency, both from a physics perspective as well as from an engineering perspective. And we'll use that as a context. I'll show you a brief demo of what that software is capable of doing, so that you have an idea of, I'll be showing you examples as well from classroom interaction. So those examples would start to make sense. Now, before we proceed, Pankaj, can you distribute that worksheet? So Pankaj will be distributing a worksheet, and it has two sides to it. One side has a Venn diagram. Let's ignore that for now. On the other side, you'll see a table, something like this. And what I want you to do is spend about 10 minutes filling up this table. So the first two columns of this table only. There are 3 rows. So try to identify 3 topic areas from the domain that you're from. You may be from civil, you may even be from English, maybe mechanical. So identify 3 very broad topic areas, and then within each of those topic areas identify at least 2 to 3 challenges which your students are facing or may face while understanding a particular concept. So for example, if I again take the case of say if the topic is heat transfer, then challenges might be understanding radiation, or like understanding how insulation works, like those sort of things. Does the activity make sense? So this is all contextualized in your own domain. So if you are from civil, you'll have a different topic. You'll have.
So the last one.
No, only the first 2. Only the first 2. We'll come to the last column at the very end of the workshop. So just the first 2 columns for now.
What about faculties who have not started teaching yet and don't know what was
Okay. What's your area?
I'm in physics.
You're in physics. Okay.
So like second semester classes have not started yet. So I don't know what the students
Okay.
lack into.
Okay. But there must be some really hard concepts in
That I have to put from my point of view.
Yeah, you can put that. You imagine like what a student might face. Yeah. All right. And if you're still working on it, that's fine. We'll come back to it towards the end of the workshop. The idea here is that the challenges and the topics that you have listed here, throughout the workshop as we are discussing, try to think about how whatever we are talking about can be used to solve those challenges to some extent, or at least, if not completely solve, but at least like reduce the problems that you've identified. Regarding the language issue, we won't be going specifically in depth about that, but if it's, how many of you have language issues in your classroom? Okay, well, towards the end, we can have a short discussion based on my previous workshop last week. I can share some things which I learned from the participants there, and you can tell me how, if it works or won't work in your scenario. But let's go down to, so if you flip your page now, you'll see this Venn diagram. We'll come back to the table, as I said, but for now, let's zoom out and focus on this Venn diagram. So there are three essential components that we'll be touching upon today. One is content knowledge. You already have expertise about the content. For this particular workshop, we'll use the content knowledge of heat transfer. Try to map the strategies that we are discussing to your own content area, and we'll see whatever is left out. Then the pedagogical knowledge is the teaching strategy, teaching and learning strategy. And then technological knowledge. How much do you know about the technology? How conversant are you with the technology that you'll be using and all? What we'll be doing is focusing at the intersection. So PCK is pedagogical content knowledge. TPK is technological pedagogical content knowledge. TCK is technological content knowledge. So you see, like, these are overlaps between two of these components, and then at the very center it says TPAC. So TPAC is a combination of all the three components. So technological pedagogical content knowledge. And this was initially suggested by Mishra and Coelho, the names of the authors right there. So it comes out of a long history of research with pre-service teachers as well as in-service teachers like you. So it has been tested before, it has been tried out before. So let's see what these different intersections are about. So PCK, pedagogical content knowledge, it talks about knowledge of teaching and learning strategies that is applicable to the teaching of specific content. So again, think about the specific content which you have identified in your table, and it's combining that with teaching strategies. It's combining content with pedagogical strategies and to teach that particular content. Then TPK. TPK is technological pedagogical content knowledge, technological pedagogical knowledge. So it's knowledge about using some specific technology to support implementation of some specific learning and teaching strategy in your classroom. So in this case, you see there's no C, so there's no component part. So right now, when we are talking about this intersection, we need not be worried about what content are we focusing on. The next intersection, TCK, is technological content knowledge. So knowledge about using technology for teaching specific content. So quick revision, the first one was combining pedagogy and content. Second was combining technology and pedagogy. And the third intersection is combining content and technology. So, and the intersection is combining all these three together. So knowledge about using technology to implement specific pedagogy to teach specific content. Again, this sounds very abstract, but keep on thinking in terms of the content which you've identified in the table, and then we'll map it to the examples that we can do. And when we talk about technology, there can be two very broad different types of technology. One might be generic or general, and second might be content specific. So general might be web-based environments, any office tools like Microsoft Office tools, multimedia, smartboard, movie makers, even YouTube, if you may. So you can treat them as general technologies which you can use to teach a variety of content. Then the second is content specific. For example, there might be very specific graphing calculators, or the software GeoGebra for teaching algebra and geometry, and then Geometer, Sketchpad. And the example which we are focusing on today is Energy 3D. It's a content specific software for teaching heat transfer and energy efficiency. And also in terms of pedagogy, there can be many different types of pedagogy. So there could be project-based learning, inquiry-based learning, case-based reasoning. Now these might seem like buzzwords to you. We won't have time to go into detail in each of those, but I'll briefly touch upon these as I'm presenting different examples. But the central idea in all these strategies is that you're trying to engage the student in a collaborative work, and by allowing them to solve authentic problems. So authentic problem means that problems which experts in your domain may be trying to solve, and you're allowing the students to work on those problems to the extent that they are capable of, and you're providing the support in the classroom as you're facilitating that sort of interaction. So let's see what each of these intersections mean. And now we'll be sort of like delving a little into different types, different ways in which you can facilitate this sort of interaction in the classroom using this knowledge. So this is about you developing a pedagogical content knowledge. So your knowledge of teaching and learning strategies that is applicable to the teaching of specific content. In this case, heat transfer. So the first strategy might be to problematize students' knowledge. So what happens in problematizing? Problematizing is basically you're questioning what the student knows, what the student is coming into the class with. So you're challenging his or her learning, or whatever knowledge they have about a particular content. You are encouraging them to recognize certain assumptions about that concept that you want to teach, and you are encouraging them to come up with detailed explanations. And you're also encouraging metacognition. So does anyone know what metacognition means? Have you heard of the word before? Okay, good. So the next session, the person coming right after me today will give a detailed workshop on metacognition. But at a very broad level, it means thinking about your own thinking process. So whatever the students are doing in the classroom, they are having some reason behind why they are doing certain things. So if you encourage the student to reflect on that thought process, then you're encouraging metacognition in the classroom. So trying to think why they are taking certain decisions or thinking in certain ways. So few examples again based on the energy 3D. Let me give okay, I missed this part. So since you have not seen the software, let me give you a brief demo of what the software does. So this gives you a platform to, let me start from the beginning. Okay, so there's a foundation that's already given to you, and you can select a pre-designed house or you can design your own house, and you can change the place where this house is located and the date, time, everything else. Uh, how that affects is that if you have a house in Mumbai, it will have different energy requirements from a house, say in Chicago or Boston or in Japan. So it will have different energy requirements based on the relative position of the sun to the house. So what the software helps you do is sort of like analyze how much energy the house is consuming um, in a day as well as throughout the year, and the different factors that might be useful for reducing the energy consumption of the house. So it lets you visualize where the sun is relative to the house at different times of the day, and you can animate that and see how the sun is moving relative to the house. Um, and then let me fast forward it a little bit. And then you can start to play around with different ways in which you can reduce energy consumption. So you can put solar panels, you can reduce or increase the insulation of the windows, doors, as well as walls and the roof. This representation on the right, the pie chart, gives the cost breakup of the entire house. Then it lets you analyze the energy consumption that we discussed just now. So it's showing that it's focusing on the, the very basic or the biggest energy consumers in the house, the heaters and the air conditioning. And we won't need the heater in Mumbai. So it's giving the value of 0. And then next to the AC, you'll see that the numbers are increasing. So, and then the solar panels, it has a minus sign in front, and there's another number in brackets. So that's basically saying how much energy the solar panels are generating, which is offsetting the energy consumed by the house. So when students use this software, they have to understand what this graph means. They have to analyze different designs that they make, and the design decisions that they are making are based on certain and based on their understanding of how to reduce energy or how to increase solar heat that's going into the house and all those things. So it sort of like combines an understanding of radiation, convection, conduction, as well as heat loss. So this is an example of a software which you may or may not use with your students if you want to teach them heat transfer or energy efficiency. Then it allows you to come up with different visualizations. So this is visualizing the heat flux of this house. And then you can put a tree and see what happens to the solar panels or the energy generated by the solar panels. Any guesses on what might happen if you put the tree near the solar panels? Efficiency decreases by? Okay, due to the tree in what sense? Like how does radiation decrease? Shadow effect. Okay. So these are like relationships which the students start to understand by putting a tree there. They see that the energy consumption goes up. So why does it go up? Then they start to get into a discussion about what's the effect of shadow, and that sort of like serves as a way to introduce them to new concepts one after another. Okay, so let's pause this here. And so I showed you a software. This is openly available. It's a Java-based software. You can run it on pretty much everything apart from Chromebooks or the Google operating system. But the idea here is that you can actually use any other software as well. So some of you may be using MATLAB. If you have access to YouTube, even you can use that as a way of introducing your students to different content areas. But the idea that we were talking about, let me come back to the slides now. So we were talking about pedagogical content knowledge, and we were trying to understand how to question what the students already know in your classroom. So some examples based on this demo that we just saw is, so these are the sentences in the quotation marks are sentences which the teacher in the classroom gave to the students. So for example, the student may have come up with a design of a house, and then the teacher questions them, what about the excessive heat gain through the windows in the summer? So the student may not have looked at summer, he or she may just have focused on winter months, and it would be a different kind of design if you just look at one season, because the seasonal variations would affect how much energy is consumed by the house. So what the teacher here is doing is sort of like questioning the student's knowledge or the student's design. Or another way to question might be, why do you want to place the window on that particular side of the house? So you are essentially encouraging the student to come up with explanations and give reasons for why they have designed the house in certain ways. Let's go back to some topic areas or content which you had identified. Does anyone want to share how this might look like in their own area? So can I have one challenge which you might have identified, then we'll sort of work on how to problematize that. So go back to the table, just read out one challenge. Yeah.
Since I'm teaching design of machine element.
You're teaching what?
Design of machine element.
Design of?
Subject in mechanical engineering.
Okay.
The numerical are to be done evaluable.
Okay. Okay. So it's is it very theoretical?
Not theoretical, it's a process type. You have to do this very well.
Okay. And does it have any application?
Yeah, there is application.
Okay.
Not in that college. No experiment.
Okay. So in your class, you are having them go through the process and helping them learn the process. Is that okay? And the challenge is okay.
I have to tell them how to solve numerical.
Okay.
It takes 1.5 years. They exhaust.
Okay. So so you said there's an application for that particular numerical, right?
Yes.
Okay. Do the students know when they're solving the equation where the application is?
Yeah, they know, sir, but they don't know where they apply because they didn't have experimental lab.
Okay. So one way to problematize in your case may be that, so you said there's one process that they have to learn, right? So, and when you let the student solve this equation, they may make mistakes while solving it, right?
And if there is one mistake, all things is wrong.
Right. So, one possible way might be to ask them, like instead of giving them the right answers, you ask them like, so why did you do this step in a certain way? Like have them explain to you why they made some certain, why they took those steps, which may have led to the wrong answer at the end.
Lack of basic knowledge as well.
Okay.
Like
Mm-hmm. Right. So that's another challenge, and you can think of it in terms of like a big problem which you're trying to break into small parts. For example, which the equation one which you just mentioned, that seems to be like a process-oriented thing where the students they have to understand why certain steps follow, why step 2 is following step 1. Like what's the reason for that? So if you're able to explain that to the students in a way that um, sort of like helping them reflect on that process. Can you come up with a question that might help them do that?
Design of cylinder block.
Uh-huh.
For that you have to do everything.
Okay.
Like how much stress is generating,
Mm-hmm.
energy is generating,
Mm-hmm.
like that. 7 to 8 processes there.
Okay. So these questions that you see up there, can you phrase a question which would be relevant to your topic area, this particular case?
Like design a cylinder block.
Okay. So that's sort of like a statement. Can you rephrase that as a question? So when you say design a cylinder block to achieve something, that's still a statement.
Yeah. Design a cylinder block with 110 cc engine. Like
Okay.
that. Four should be that, and length should be that.
Okay. So how would you design a cylinder of to certain
110 cc
requirements?
engine.
Mm-hmm.
Simply the bore should be that, the length should be that,
Mm-hmm.
and maximum temperature should be that.
Mm-hmm.
They have to cope up with all these things.
And while answering that question, they would go through the numerical process, right?
Yes.
And while they're going through the numerical process, you can keep on asking them like, why did you do it this way? Why don't you try this out? So sort of like helping them think through the process rather than just um, like memorizing the process.
An example,
Yeah.
one question I will solve there. It is not possible to go everywhere because I am single and they are 60.
Right. I'll come to that. So that's a good segue into the next part. So peer-to-peer learning. So right now we are not focusing on technology because this is the intersection which does not have the T there. So we have a problem in the classroom where it's not possible for the teacher to engage with each and every student on a one-to-one basis. So how do we go about that? So there's a very effective teaching method where you can have the students collaborate with each other, and you can make groups of 2 or 3. 3 is like an optimal number. 4 starts to get a bit problematic because there might be one student who doesn't want to work, so he's like a free rider in the group, and others sort of like start to get worried what will happen to their own grades. So you can make groups of 2 or 3, and then you encourage collaborative work, promote peer critique. So in your case, for example, if you're making groups of students to work on this particular problem which you gave them, and they'll come back to you with certain questions like, I'm unable to do this, I'm unable to do that, and there you are helping them sort of like move forward by giving them guiding questions, not giving them answers, but giving them guiding questions. And those questions can be in the form of, why don't you try this out, why don't you try that out, see what happens when you do this. Sort of like nudging them along towards the final goal that you have in mind as the teacher in the classroom. And what happens in peer-to-peer learning is that since like the students are trying to come up with or like working on the problem together, there's a very high motivation level. They are not expecting the teacher to be always there to give them the answers. They're trying to come up with the answers on their own, and because they're learning, they'll obviously struggle with it. But you as a teacher can then intervene because there will be a lot of common struggles in the classroom, and then as a teacher you can sort of like maybe focus on what are the broad challenges that different groups are facing in the classroom. So some ways of encouraging peer-to-peer learning might be that some student in the classroom may be really good at this particular equation or has learned this equation very well. So you can direct students or groups who are facing problems to those students and say like, make them as experts in the classroom. I mean, they're students, but they can be experts in their own sense. So you can appoint them as experts. So, for example, in this case, the teacher said expert Samir and Lakshmi will come to you and help you reduce heat loss. So this is the case where a group is having issues trying to reduce the heat and the heat loss, and they're unable to do it. So what do? The teacher directs them to the experts in the classroom. So you're engaging the students in peer-to-peer conversation, peer-to-peer discussion. And the third way of doing this, might important thing here is to connect science and engineering. So oftentimes what happens is that students are focused on either the science part or the engineering part, so they are unable to connect why certain things are happening. So science would help you explain why some engineering phenomena are happening or not. So for example, in the example which we saw, when students are asked to interpret the graph, they sort of like just focus on the mathematical numbers. They don't understand what the numbers mean, and how the graph would help them reduce the heat loss or heat transfer in the house. So again, some possible prompts would be, why do you think the solar panels are not generating enough electricity? So again, these are like why questions or what questions. What happens when you do this? Um, the next intersection is technological pedagogical knowledge. So here it doesn't have the C part, the content part is not there. And again, we see that there's a peer-to-peer learning, but here with technology is happening. So again, taking the previous case, you are encouraging the students to co-construct knowledge or like co-construct investigations. In this case, the students can work in pairs and use the software. If you're using MATLAB, they can work in pairs, see what, like sort of like work on the MATLAB problem, and then like engage in collaborative work. If you don't have access to MATLAB and if you have access to internet, you can use YouTube as a resource. And you can again have pairs of students interact with each other and look at the example in the YouTube video that you're suggesting. So what will happen is that when two students are looking at it, they might have different perspectives. And that sort of like starts to get into, someone may say that I think this is what is happening in the video. Someone may say, no, I think this is what is happening. So they get into sort of like a healthy debate or argumentation. And if you let that, if you allow that in your classroom, what would eventually happen is that students would start to get more motivated in the content which you're trying to teach. And at certain point, you can intervene if you see that the conversation is not going in a productive direction. You can again sort of like mention, or you can give hints or guiding questions to sort of direct the conversation in productive ways. And what that also helps you achieve is giving ownership to the students. For example, like in this particular way of structuring classroom instruction, if you look at project-based learning, so you can sort of like have a big project for the students, and then whatever you are doing in terms of, for example, coming back to your the case which we discussed just now. So the project could be designing an engine or designing some big system, and then you can break it down into smaller components of that particular part. Let's take another example. Any other challenge which you have written down and see how we can apply this to your case? How can we give ownership to the students? How can we help them become experts at the content that they are learning in the classroom? I'll share some prompts. So for example, like again coming back to Lakshmi's example. So talk to Lakshmi to find out how to place solar panels and how to resize the house. So in this case, Lakshmi may have come up with a solution and other students dealing with that. So you're appointing Lakshmi as an expert, so giving ownership of that particular content. You're assigning a role to a student. So let's take one more challenge and see how we can apply it in that case.
All this process, it has been assumed that the student in the class have some kind of basic knowledge as to know that where they have any problem.
Mm-hmm.
But in the situation we are,
Mm-hmm.
but they don't know.
Okay. But they are unable to solve whatever you're giving them, right?
Yeah, like they are unable to solve, that's one thing, but they don't even know what their like shortcomings and where
Okay.
they lack.
So how are you addressing that right now? Like what do you do in class right now? Or like what would you do?
For my subject,
Yeah.
classes has not started yet.
Right. So what would you potentially do?
I'm clueless. Like,
Okay.
so right now my plan of the thought is that I'll be going and I'll be completing my syllabus, and in between I'll be taking some assignments and some quizzes.
Okay.
In that process, I can make an assessment if they are then they are getting something or not. But
Okay.
it's for me, like right now it seems all hypothetical or too idealistic to be implemented.
Uh-huh. Anyone else has a problem like that in their classroom? Okay. Have you come up with a solution which seems to be working?
He's right, I think so.
Uh-huh.
But he's saying it has to be the practical implementation.
Right.
Area.
Sure.
Here it can be a different thing. We can look up all these because the basic stuff is so neat and clean, and then you can take from here. But we have to generate that stuff before we take on off from here.
Okay.
This is for a place where almost infrastructure is available, where you can show YouTube videos in the classroom. I cannot show YouTube video on my mobile to the whole classroom.
But they have phones, right?
So everybody will be watching their phone, and so I cannot check that everybody is watching that same video.
Yes, you don't need to check that, but you can structure the classroom in a way where after watching the video, they would have to answer some questions or engage in an activity where that knowledge would be applied, right? So if the student has seen some other video, then that student will not be able to apply that knowledge. And you can assign marks or whatever you do in the classroom to hold them accountable to whatever you have assigned them to do. So you don't have to go around and check if they are watching the video, but you can certainly tap on any sort of assessment or evaluation which you can design around the content which they are watching. And coming back to that issue of like the students not having the basic knowledge, that's a valid concern, and this need not be idealistic. The example that I'm showing you presents it in an idealistic way.
Like in that case, you are showing that Lakshmi knows that how to place the solar panel.
Right.
That's it. Not even a single student
Okay.
knows how to tackle a problem. So I cannot assign someone to do the
Right, so that may not be applicable in your scenario. So you can sort of like fall back on the peer-to-peer learning process and sort of like make pairs of students. But at some point when the students are actually engaging with the content and doing what they are told to do, then you can at some point they'll learn some content, right? So even if it's basic content, for example, if it's very basic, like okay, so what can I think of? Say even a basic understanding of friction, how friction works. So a student may come to your class without having that understanding, but you may try to teach a concept which uses the basic knowledge of friction. So one possible way here in this case technological, if you try to apply this particular framework, what you can do is have them complete an activity at home or like before they come to class. Find some YouTube video which sort of like gives an introduction to friction and have them review that. Then structure some basic questions around where that knowledge may be applied. So you can make sure that they have actually reviewed that video. So once they come to class, they can be better prepared than they were before they saw that video. That's just like one example of how to work around that problem. So actually, before I proceed, let me check. Any other burning questions like that which are stopping you from imagining this in your classroom? Content related, not infrastructure wise. Technology, like we just discussed, everyone has a phone nowadays. Pretty much everyone has a geo connection. So they have access to internet pretty much everywhere now. It's a matter of sort of managing the use of those phones in your classroom if you don't have anything else. If you have a computer lab, if you have laptops, if you have computers, and if you have internet connection, then there's nothing better than that. If you don't, there are other means of sort of other ways of using, sort of like coming up with other technologies which you can use. Any other problems like that which you're facing in your classroom right now? Yeah.
Another problem is like there is a large difference in skills and intellect among students.
Okay.
Like there is no common way to deal with all of them.
Okay.
Like if I'm explaining a concept for a couple of students, they need only 2 minutes to understand the concept.
Okay.
For 30 of them, they may need half an hour.
So
if I'm moving along with the students who can understand in 2 minutes, the other people will be
okay. So one possible strategy, again, if you look at this framework, and if you're thinking of using a peer-to-peer learning model in your classroom, you can make pairs of students who know something really well, and students who may not know something really well. So then you're sort of like having the students tap into their own knowledge and having them explain to their peers how something may be working or how to solve something. And even the experts may not know everything. But they are certainly at a higher level in terms of their skill set than other students like you were just talking about.
If I'm explaining something for the first time,
Right.
whose pace should I choose? The students or
so there's no right answer to that. If I were teaching in that classroom, I would go with the least common denominator in the classroom, the weakest student in the class. But then again, that would mean slowing down your entire syllabus and sort of like maybe disengaging other students in the classroom who are at a higher level. So in that case, you have to take a call on how you want to structure your classroom. So I, as a teacher, may want to introduce the topic at a very basic level, then pair them up like experts with not like non-experts, and that would sort of automatically, after a while, raise the level of the entire class to at a certainly a bit higher level than what it was before, right? Then that sort of like gives you another entry point into that topic area. So it's sort of like a step-by-step process. You won't. It's always true that in a class of 60 there will be people with many different skill levels, and there will also be 5 to 10 students who don't want to learn anything from you. So whatever you do, nothing will work on them. But you as a teacher, your goal, I understand your goal is to complete the syllabus, but your goal is also to help the students understand what they are learning. So if you are following these strategies, it's not really taking the burden off you as a teacher, but it's letting you be more productive and giving you more time to facilitate a deeper conversation around the content. So for example, in your case, if there's a student who's having problems, again coming back to the friction example, so if there's a student who has no idea what friction is, I may pair that student up with someone who is already familiar with the concept of friction and give them say 10 to 15 minutes to work on some problem which uses the concept of friction, and that will sort of help the student know learn the concept, as well as sort of the student who is explaining, that student will also benefit because he or she is reflecting on what he or she already knows. So that's also a valuable process. Does that sort of answer the question which you posed to some extent? Okay. And again, none of these are perfect strategies. You'll have to see what works in your classroom, what doesn't work. You can combine them, you can modify them. Yes, you had a hand up.
How to generate interest across students while delivering other department papers? Then taking BEE paper in civil department first year.
Okay.
How will you generate interest across them? Because it is not of their core syllabus.
And
they are simply telling that why you should study this paper.
so is there something that so when they suppose you have an ideal student who wants to read that paper, after reading that paper, how will he or she benefit from it? Is there an application to that, or is there some other
If they will go for PSU, then because in every PSU departments papers will be there.
Okay.
Mechanical, electrical, and civil.
Okay.
So they have to study this thing, but they don't want to study. They are simply telling this not our core paper. Then why to study in this?
Okay. Let's hold that question for a moment and see if some things get clarified on the discussion, and we'll come back to that question. Yeah. Yeah.
Classes of 60.
Right.
Here, what is happening is that 20 are coming today, 20 different are coming next day, and 20, 30, 20 next are coming.
Mm-hmm.
If I try and choose them, some leaders, some will come, okay, common. If I choose them as leader, they will be in explaining mode, definitely. So how to move forward with the syllabus then? That is
Can you, so if you're making pairs and you're assigning, and this is just like I'm thinking on the fly right now, if you're making pairs and you're assigning grades or marks based on what the pair does or what the group does, can you make the students be accountable to each other for showing up in the classroom?
the marks component that is with in a particular course is 20 marks total.
Right.
In a semester, and they don't even bother. Maybe some cases they don't bother. The last 10 or 20 that they are impacting the toppers also. Then slowly it's becoming a cycle. So they don't care about 20 marks. They can score 80 out of 24, 30, and they will pass. So that 20 marks component is not that much.
Okay. Again, I mean, I don't have a good answer to your question right now. But one thing that's coming to my mind is making, like, if you can in some way like make the students be answerable to other students who are coming to the class. Not to you as a teacher, because you are at a different level for them. But if there's peer pressure amongst the students, you're making peers of students and like making them accountable for the work that they're supposed to submit or do. May not be marks in this case because you're saying it's not as valuable.
I think that all these things are dynamic. Whatever happens in the class, you have to handle it there itself.
Right.
The theoretical things may happen in some case at a point of time, we don't know.
Right.
But initially we have to handle it dynamically.
Sure. And that's perfectly acceptable because you as a teacher would know your class best. And what we are essentially doing here is giving you some additional, letting you know about some additional strategies which may become useful to you at some point later on.
What to do when students continue doing mass bunk for weeks?
I don't have an answer to that, sorry.
2 months of direct.
Right. So we won't go there because it's like again, it's sort of like a more of an administrative issue now. But right, but you have control over the way you are teaching the students who are there in the classroom.
But that will happen if the student comes. First, even one student will come, then we have a teacher.
So like I said, you will be taking these strategies with you wherever you are going. So right now where you are may not be the most ideal scenario for you. It may be a stepping stone or a step towards a better working environment for you. So there's no reason to believe that it would stay the same way forever, right? So if you have these techniques at the back of your mind, somewhere someday this might click. Oh, okay, I learned about this in that session, so maybe I'll try using that and see what happens. And again, I mean, these are not bulletproof answers to your questions. But these are different strategies which we have seen work in classrooms. So kind of coming back to the session again. So right now we're focusing on technological content knowledge. So we are not worried about the teaching or learning strategy. We want to see how we can use a particular software or technology to teach a particular content. So you can help the students make meaning help the students understand what different things in that software mean. So if you're using MATLAB, you can help them understand what different analysis they can do with MATLAB, or what different visualizations they can run. If they're using YouTube, you can very well review the video with them to sort of make sure that they understand what they are looking at. In this case, again, the teacher there is giving them a brief idea of what heat maps are used for when we are using Energy 3D. And this is something which I had briefly touched upon before, problem decomposition. So when you are trying to teach a particular content, and you can break it down into simpler problems, like a big problem. So in this case, going back to that first example about like designing a cylinder or something like that, right? So that can be broken down into smaller problems, and there might be YouTube videos or some other softwares to help students address those smaller problems, and then you as a teacher can bring it together. So once they have tackled those smaller challenges, you can combine those challenges and help them see how it relates to the bigger problem. And this is a strategy which is used very often in a lot of different scenarios, like problem decomposition. Like breaking a complex problem into smaller, simpler problems, which would make more sense to the students. And so finally, like at the intersection, what we are looking at is how to promote technological pedagogical content knowledge. And this is for you as a teacher, like how do you want to inculcate that sort of habit in your teaching style. And coming back to the peer-to-peer discussion and peer-led inquiry learning, which is again like creating space for the students to work in groups and iteratively improve whatever they are doing. And we had touched upon this before. So pairing students with knowledgeable partners to learn the content using some particular technology. And you're also promoting reflective questioning and troubleshooting. So challenging students' knowledge while they are using the software in certain ways. Now let's go back to that table again and see if whatever challenges you've identified, see how, and you can flip the paper and see the Venn diagram and consult the Venn diagram as well. But see if you, and work in pairs. Now like you're setting a table, so you can make groups of 2. If you don't have a partner, you can find someone. I see 2 people without pairs. See if you can come up with some solutions to the challenges which you've identified, and try to be as optimistic as possible in this case. Because again, I mean, these are strategies which you're taking with yourself. These are not administration dependent. There's nothing to say that PCK is definitely applicable in this scenario. Okay, so let me show you one example really quick. So this is a very hypothetical scenario here. So Samir is trying to optimize the design of his house. Again, we are using that same example. But what I want to show you is that there are 4 possible solutions to this particular challenge in the classroom. But each solution will lead to different ways of interaction with the student. So you as a teacher, if you want to be well prepared for the class, you can visualize yourself having a conversation. In this case, conversation with Samir. What would that conversation look like? If you're following PCK, there's no T or technology involved in it. So you're essentially helping, you're essentially resolving this particular situation without using technology, and that is perfectly fine. You can use technology as well. There's no one to say that solution 2 is better than 1. It's you as a teacher have to make a call of what would work best in your scenario in that particular case. So all answers are right. It's just the nature of conversation with the student, and whatever help you are giving the student, that would change. And the other point about the language, I was having a conversation just now. So in my workshop last week, one participant said that what he does is, he applied the framework, and then he said that what he does in class is, he asks the students to come up with very simple, so he asks the students to identify topics from their own area of interest. Doesn't have to be content related, could be from politics, sports, anything. And then they have to give a 5 to 10 minute presentation in English, because English seems to be the problematic language, right? So this particular teacher has flipped it around. Like, instead of teaching English to the students, is essentially having the students come prepared to the class with a presentation in English to be delivered in the class to other students. So it's essentially giving that space in the classroom, say 5 to 10 minutes. Could be on weekends if you have remedial classes, could be extra classes on weekdays as well. But instead of teaching them the language, you're having them do the work and coming to the class prepared with presentation and sharing that with the class. Then you can have other students. So again, going back to that peer-to-peer conversation, you can have other students critique what that presentation was about. So that's another way of seeing like how this framework might help, or like think through certain problem scenarios. So that's one way of tackling the language issue, which a lot of you have mentioned. But let me take one or two potential solutions to some challenges which you've identified. So based on the group discussion, why don't we share one? Do you want to share one solution to a challenge which you've identified?
My challenge in for the basic electrical network circuit, in which the student cannot solve complex numerical problem. Network circuit or circuit analysis. The student cannot solve the complex numerical problems. So my solution is make them allowing. First is the making the groups of 3 students, and second is the use of the simulator,
Okay.
or software tool.
Okay. So you have access to a simulator, or may have access to a simulator.
Yes, it's
Okay.
available.
That's good. So once they have access to the simulator, then how you as a teacher, like how would you facilitate that interaction? So they are using the simulator, and they are maybe simulating.
They can
the network.
use.
They can use.
They can use
Okay. And then
in lab.
Right.
Yeah.
So then you as a teacher can sort of what we talked about, like the meaning making process. So maybe you can help them understand how the simulator works, ask them questions to facilitate that conversation with the student. Okay, very good.
Out of 30 student batch, when they are coming, I've pointed out the weakest link, who is not understanding the things, not doing the things in fact, and make him sit on the projector and do the things, code it down. Then he made so many mistakes, then everyone was pointing out the mistake. So then they start learning that at least we don't do silly mistakes. Still they are
Mm-hmm.
trying to do improve. So that's what I implemented.
Okay. So
And while explaining when they are making mistake, I am trying from the back, I am insisting that this is the mistake, line wise I am explaining that I have did.
Okay. So do you tell them what the mistake is, or have the students?
Give them 20 second 30 seconds time that what is the exact mistake in this particular code. For example, after void main they are putting semicolon terminator. This is the first third line and they are doing mistake. So very basic. Some are not doing, but some are doing. So I pointed down them and made them on the project directly.
So which of these intersections do you think like your solution
I feel
solves?
it's in the content.
It's in the content knowledge. So you use
PCK mode.
PCK mode. Okay.
Sir, as we studied different currents flowing in a transistors, then for students it's difficult to imagine or they are not able to imagine the flow of current in direction, because there are 3-4 types of currents flowing in different directions, because none of us have seen the flowing electrons. So the possible way to make it happen is using TP gate, technological pedagogical knowledge, by showing them some videos, PPTs or MATLAB simulations. So it may be a possible solution for that.
Right, that's a good point. And also like when they're, again, the question goes back to you, when they're watching the videos or these simulations, then they should have some like guiding prompts for them, like so that they know what to look for, because since they're new to the
If they miss something, then they can easily get it through videos. And
right. And you may also make them look at the videos in pairs so that they start to have a conversation around that particular concept, in this case the direction of flow of electricity.
yes.
Very good. All right. So I hope that you will continue to have discussions or like this among, because most some of you are from the same college, but also wherever you are going next, you will carry these strategies with you. Keep this sheet of paper with you. It's always helpful to think of bigger problems in smaller parts. So try to decompose bigger problems and then attack those smaller parts and see if you can combine the solutions to those. All right, thank you.